Thank you for inviting me to give this talk today. So my name is Ellis Solomon, and I'm here to share insights into our project, Excel AI Project, which successfully progressed from phase one to the full proposal stage of the UKRI Cross Research Council Responsive Mode pilot scheme of last year, 2023. So I'll aim to provide an overview of the project and discuss key factors that we believe contributed to the project successfully progressing to the next stage, and share some practical advice based on the feedback from the review process to help guide future applications. So what is the project about? So Excel AI aimed to tackle the black box nature of AI systems, artificial intelligence systems, by developing explainable AI methods that are specifically tailored for use in education and insurance. So our application areas for this project, our scope was the education sector and the insurance sector. So for example, an education AI might predict student performance, but without clear explanations, and therefore it gives certain predictions, but without explanations as to why it gave certain predictions. Teachers might struggle to trust or act on these predictions. Also, students might not trust the predictions or the advice given based on the AI if there isn't a clear explanation, and they might just ignore it and not use the AI education system as it was intended. So similarly, in insurance, AI might make decisions on claims, but policyholders often find these decisions opaque. So our proposal was to make AI decision-making processes more transparent and understandable, enhancing trust and usability by tailoring explanations to specific user needs within specific contexts. So we're saying that different users within different contexts need different explanations for AI decision-making, and our aim is to study how we can create these contexts and user-specific explanations. So our objectives, they focus on co-designing explainable AI models with stakeholders. So it's a co-design process, and this aims to ensure that they are relevant and useful. For example, we aim to involve teachers directly designing AI explanations that align with their needs for understanding student assessments. We also aim to advance existing explainable AI tools to make them more adaptable to specific contexts. So, such as insurance claim decisions that need clear, understandable justifications. And to measure the success of the tool we're going to develop and similar other tools, we aim to develop something called the EX Square Index, an explainability index, which is a tool to evaluate the effectiveness of these models, these AI models from different perspectives. Finally, our research questions are designed to explore how we can achieve these goals while ensuring AI explanations meet legal and ethical standards. So one of the key requirements of the UKRI cross-council scheme is for it to be interdisciplinary. So that's one of the key requirements to receive the funding for particular projects. So the interdisciplinary nature of our project is, I believe, one of our strongest aspects. So we brought together experts from computer science, from human-computer interaction, from social sciences, law and ethics to address the challenges of AI explainability from different angles. For example, why computer scientists work on improving AI transparency, social scientists will examine how these explanations affect user trust and decision making. Our legal and ethical team aims to ensure that the models align with standards like GDPR, tackling concerns about data privacy and bias, and by integrating these perspectives, we create solutions that are both technically robust but also socially and legally sound, ensuring that AI is practical, usable and compliant, and that it has wide impact and real impact. So let's consider a couple of examples. In education, AI systems often personalize learning by identifying patterns in student behavior. So there are tools around. Um, One of the tools is called SHAP. So this tool might point out that a particular feature 37, affects a student's grade. So this, so a computer scientist might be able to drill down and figure out what feature 37 means. But this is not intuitive for teachers who need actionable insights and they need more clearer explanations of what this feature means. So our aim is to reframe this and to explain something like student A's performance is influenced by increased absences and low participation, which would be much clearer and directly useful for educational decisions. Similarly, in the insurance sector, AI often provides technical explanations for claim decisions. Again, it'll say something like feature 9 has influenced the outcome, and this information is not very helpful for claim adjusters or policyholders. So with our proposal, we will say something like your claim is approved due to a low number of previous claims and comprehensive coverage, which makes the decision process clear and relatable. So these examples demonstrate how our proposal bridges the gap between AI's technical outputs and user understanding, and how the decisions are tailored to the specific needs of each domain. So some insights from the feedback. So XLAI was graded as band A, which was the highest rating possible, reflecting our wide approach, our comprehensive approach to the course criteria. So the feedback highlighted our strong interdisciplinary integration and effective collaboration among team members from various fields. One of the key factors in our success was clear demonstration of how different disciplines like AI and social science work together to co-create solutions. For example, we didn't just add a social science component, we showed how insights from social science directly shape the AI models, ensuring that they met user needs more effectively. So we believe that this co-creation process was central to demonstrating the added value of an interdisciplinary approach. Our alignment to the scheme objectives was an important factor. The scheme prioritized interdisciplinarity, novelty, and transformative potential, and we aimed to make that very clear within the proposal of how our proposal was novel and transformative by integrating all these different disciplines and therefore having a wider impact. So for example, we showed how combining HCI with AI could create more intuitive interfaces that directly improve user understanding, and making it clear that this can't be achieved through traditional AI methods by themselves. And from the feedback, it was evident that successful proposals were those that didn't just bring together multiple disciplines, but that integrated them in a way that each discipline contributed, creating a unique high impact outcome. So in terms of advice for future applications, I recommend focusing on demonstrating true interdisciplinarity. So it's not enough to simply list multiple disciplines, you need to show how they are interwoven into the fabric of the project, highlight the reciprocal benefits, how each field informs and improves the other fields. Avoid adding disciplines just to appear more comprehensive. Quality integration is more impactful than quantity. And finally, clearly articulate the expected impact of your research, aligning it with the scheme's goals. So be specific about who you will benefit and how, using clear examples to make your case as compelling as possible. Yeah, I think just on time. So thank you for listening, and if you have any questions, this is my email address. I'm happy to talk further about this.